Ever stop and wonder how your apps can find your single piece of data in a sea of billions of users and do it like instantly? Well, today we're going to pull back the curtain on the powerful yet super simple algorithm that makes it all happen. And here's the kicker. It's something you already do every single day without even thinking about it.
I mean, really think about that for a second. You go to log into something massive like Facebook. It has to find your username out of literally billions, and it does it in the blink of an eye. How is that even possible? Well, it's not magic. It's just a really, really clever way of looking for things.
And the secret? It's something you already get. If I handed you a big, thick phone book and asked you to find Smith, you wouldn't start at the A's and flip every single page, would you? Of course not. You'd crack it open somewhere in the middle. And that instinct, right there, that's the whole trick. To really appreciate just how brilliant this is, we first have to look at the obvious way to solve the problem, which it turns out is also the painfully slow way. So let's make this easy. We'll play a little game. I'm thinking of a number somewhere between 1 and 100. All you have to do is guess it. After every guess, I'll tell you if you're too low, too high, or if you got it right. Simple enough? Now, the most basic way to play this game is what we call a simple search. You just start at the beginning. Is it 1? Nope. Is it 2? Nope. 3? Nope. Ugh. You can already feel how tedious and slow this is going to be. And the source material just nails it. With this strategy, you're only knocking out one bad number with every single guess. So if the number I'm thinking of is 99, well, you're going to be here for a while. It could take you 99 guesses. That just doesn't work. So yeah, this is obviously not how Facebook finds you. It would take ages. There has to be a smarter, faster, just a better way to do this. And yeah, of course there is. And this brings us to the hero of our story, binary search. This is that aha moment. It's the simple, elegant idea that changes everything and makes searching through huge amounts of data not just possible, but incredibly fast. So instead of starting at 1, let's go back to that phone book idea. What if you just jump right into the middle? Your first guess is 50. Now, let's say I tell you that's too low. Think about what just happened. You didn't just eliminate the number 50. No, you eliminated 50 and 49 and 48 all the way back to 1. With one guess, half the problem is just gone. Just look at this showdown. If the number we're looking for is 63, a simple search takes, well, 63 agonizing guesses. But with binary search, your first guess is 50, too low. Okay, so now we know it's between 51 and 100. Let's guess in the middle of that, 75, too high. Okay, so now it's between 51 and 74. One more guess, 63. Bam, you got it. 3 guesses versus 63. It's not even a fair fight. So the whole idea boils down to these simple rules. Start in the middle. Check if you're too high or too low. Then, and this is the magic move, you throw away half of the remaining options. And you just keep doing that. But, and this is the big one, the absolute deal breaker. The list has to be sorted. If it's not in order, you have no idea which half to throw away and the whole thing falls apart. Now, for a list of 100, it takes just 7 guesses. That's pretty cool. But the real superpower of this algorithm, this is where it gets kind of mind-blowing, is when we scale it up. This is where we see the magic of something called logarithmic time. It sounds fancy, but I promise it's a simple idea. So, let's ditch our little guessing game and think about something bigger. Imagine you've got a dictionary with 240,000 words, all sorted alphabetically, and you need to find just one specific word in there. All right, using our old, slow, simple search method, if that word happens to be at the very end of the dictionary, it could take you up to 240,000 steps to find it. That is a ton of work. But what about binary search? The same exact process, cutting the problem in half every time. Well, you are guaranteed to find any word in that entire dictionary in a maximum of just 18 steps. Not thousands, 18. It's almost unbelievable. The math behind this is called a logarithm, and it sounds intimidating, but it's not. All it's doing in this case is asking a really simple question. How many times do I have to cut this thing in half until I'm left with just one? For 240,000, that answer is about 18. That's all it is. And just look at how fast the problem shrinks. After just one guess, you've gone from 250,000 words down to 120,000. After just 4 guesses, you're already down to 15,000. This incredible rapid shrinking is where all the power comes from. Okay, so we've got this amazingly efficient way to search. But let's bring it back to the beginning. Why does any of this really matter in our everyday lives? What's the big takeaway? This final comparison really shows it all. For 100 items, the difference is pretty big, right? 100 steps versus just 7. But look what happens when we scale up to 4 billion items. You know, roughly the number of people on some social media sites. Simple search would take 4 billion steps. But binary search, it takes just 32.
And here it is visually. The bar for simple search is so huge, it would basically stretch to the moon. And the bar for binary search, it's that tiny little sliver down there you can barely even see. That is the kind of mind-boggling difference we're talking about. So in the end, what this all means is that binary search takes a problem that would be physically impossible to solve in any reasonable amount of time, and it turns it into something that feels completely instantaneous. This algorithm, and others like it, are the invisible engines that make our entire digital world feel so fast and responsive. And it just makes you wonder, doesn't it? What other brilliant, elegant solutions like this are humming away just under the surface, quietly turning the impossible into the everyday?